Hey, my goodness. So this is our last video notes for the semester. It's a little teary for me, but it's section 14.2 in your textbook. So if you guys, and you're like, wow, quick switch, Patterson. You're obviously not that sad. If you guys need additional examples, if you need an extra look into this, that's the section you're going to go to in your textbook, okay? So let's do it. The main goal and the thing you have to remember is now you guys have an arsenal of identities. We've got Pythagorean, you've got even odd, you've got double and half angle, you've got the basic ones, and you now also have your sum and difference and your half angle. All of these are in your pocketbooks, okay? These are all things that you can use to solve equations, which is what we're going to do in a second, or to prove identities, okay? So you've played around with that a little bit, but keep in mind that that's at your disposal. Okay, so here we go. Example number 1 says to solve, and it gives us a specific interval. 2 things to notice. It's 1 revolution around the origin, okay? 0 to 360, don't go beyond that. Second thing to notice, it's in degrees. So your answer has to be in degrees. You have to keep the formatting consistent. Okay, you might want to write that down if you're forgetful. So make sure you keep it consistent. I see sine squared, I see a cosine double angle, and I see a cosine of x. I don't want to solve for various trig functions. If I can, I would like to keep it consistent. I would like to keep it the same. So right away, I know that I can change sine squared to be 1 minus cosine squared of x. And I know that I can change cosine double angle to be 2 cosine squared of x minus 1 minus cosine of x. In changing the sine squared using the Pythagorean identity, and in changing cosine double angle to be cosine of x, or cosine squared, pardon me, that means that now every trig function in this equation is cosine, be it squared or singular, and I can solve a little bit easier. So now I'm going to combine like terms. Well, the ones are going to cancel, and then negative cosine squared x plus 2 cosine squared x is going to give me cosine squared of x. And then I just have a negative cosine of x left equal to 0. Well, they do have a greatest common factor, and it's not a trinomial quadratic, so I can just factor out a cosine of x, and that leaves me with cosine of x minus 1 is equal to 0. Remember when solving quadratics, the zero product property, if you have 2, we'll say, factors that are being multiplied together and they equal 0, one of them must be equal to 0. And that's why when solving quadratics, you're allowed to take each of these factors and set them equal to 0. One of them must be 0. Okay, the left one, cosine of x equals 0. In order for me to solve for x, I need to apply the inverse. So x is going to be the inverse cosine of 0. And where is cosine equal to 0? Well, that's at pi over 2, or 90 degrees, and 3 pi over 2, or 270 degrees. Why am I putting it in degrees? Because the restriction was given to me in degrees. All right. And then for the right-hand factor, we have the cosine of x is equal to 1. So again, we're solving for an angle measure, so I'm going to apply the inverse. So x is equal to the inverse cosine of 1, and that is at 0 pi, or 0 degrees. Okay, 3 answers. I'm not going to put 360 because it's not equal to, so I'm just going to put 0. So x is 0 degrees, 90 degrees, and 270 degrees. I will always put my answer in ascending order. You're more than welcome to do it however you see fit, but please make sure that you put them together in one solution set. Awesome. All right, there are 2 try these. I'm going to do them with you because we don't have a lot of interaction face-to-face right now. So it's good to have a lot of examples at your disposal. Okay, again, we're given our interval between 0 and 360 in degrees. So for A, I need to solve. I need to solve for x. So I'm going to say that sine squared x is equal to 1 over 4. And remember that sine squared of x is the same as the sine of x quantity squared. So in order to get sine of x by itself, we're going to take the square root. So that means that the sine of x is equal to, don't forget the plus and minus, the square root of 1 over 4. Now travel if you will to my thought bubble. Square root of 1 over 4 is the square root of 1 over the square root of 4. Okay. If I were to take the square root of each of them, I would get 1/2. So we're looking for what values of x would make this equation true. So that means that x is going to be the inverse sign of plus and minus 1/2. The plus and minus is super important because we're not restricted to quadrants. The plus and minus means every quadrant, okay? In the first quadrant, sign is positive. In the second quadrant, it is positive. In the third and fourth, it is negative, okay? So all 4 quadrants. Where is sine equal to plus and minus 1/2? At pi over 6 or 30 degrees. At 5 pi over 6 or 150 degrees. At 7 pi over 6 or 210 degrees, and then at 11 pi over 6 or 330 degrees. So there's all of your answers. We were given an interval, so make sure you don't go beyond that. Okay, for B, try this. Ideally, because I did mention it would be nice if we could get all of the trig functions to be the same. We can't here, because it's not squared. None of these are squared. So I'm going to put everything on the same side. I'm going to take sine of x equal to negative sine x cosine x, and I'm going to add sine x cosine x to both sides. 2 reasons. This gets the equation equal to 0, and then I could potentially apply the zero product property, and they both have a sign. So if I can get them on the same side, I can factor it out. Ladies and gentlemen, never divide by the variable. Yes, if I were to divide both sides at the beginning by sine of x, it would cancel out and you would get 1 on the left-hand side of the equal sign. You would also eliminate one of your solutions. Never divide by the variable. If you need to, write that down. So now we are at the zero product property application. So I'm going to say the sine of x is equal to 0 and 1 plus the cosine of x is equal to 0. For sine of x equal to 0, I have to apply the inverse. Why? Because I'm looking for the angle measure. Okay, so we have to apply the inverse to 0. So where is sine equal to 0? At 0 degrees and 180 degrees. On the right-hand factor, we subtract 1 to both sides. So cosine of x is equal to negative 1. So x is equal to the inverse cosine of negative 1. Where is this? At pi or 180 degrees. Now 180 degrees fits 2 of these factors. You can list it twice, but it's really not necessary. So x is just equal to 0 degrees and 180 degrees. Sweet. All right, example number 2. Cosine of theta plus 1 is equal to 0 for all value of theta in radians. Yes. So now we are not restricted to any interval of space. You have to account for an infinite amount of answers and how often they happen. Okay, so I'm just going to solve. I'm going to say that the cosine of theta is equal to negative 1. Yes, again, we're going to have to apply the inverse. And we know that this happens, pardon me, cosine is negative 1 at pi. Why am I using pi? Because it says radians. But it's not one answer. Okay, so think about it like this. We are in standard form, right? And it occurs at pi. Okay, well then it occurs at another 360 and another 360 and another 360. It occurs at every 2 pi radians. So we're going to say that theta is pi plus 2 pi k, where k is any integer. You have to establish what k is, otherwise k has no value. Okay, so we've seen this before where we use k and then we establish what it means. Okay, so it occurs, pi is the first location, and then it occurs at every 360 or 2 pi radians. Easy peasy. Take a look at these. I'll do A with you, and then I'm going to have you pause, and then we'll do B and C on our own to see how we're doing, okay? All right, cosine of 2 theta. Well, I'm going to say that the cosine of 2 theta equals 1. And I know that the double angle can be changed. Now, there's 3 options. I do not want to use cosine squared theta minus sine squared theta because now I'm solving for cosine and sine. Okay, just pick one. In the theory, or theme, what? In the theme of our example number 2, I'm going to use cosine. So I'm going to change this to 2 cosine squared theta minus 1 is equal to 1. And I'm going to solve. So I'm going to add 1 to both sides. So 2 cosine squared theta is equal to 2. I'm going to divide both sides by 2. So we get cosine squared theta is equal to 1. I need to get rid of the squared. Remember, cosine squared theta is the same as cosine of theta squared. So then I'm going to take the square root of both sides. So this equals plus and minus 1. Please, 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 when you take the when you take the square root, don't forget about the plus and minus. In order to find the angle measure, I'm going to apply the inverse, plus and minus. Okay, now be careful. It said degrees. So theta occurs at positive 1 is at 0 degrees. Negative 1 is 180 degrees. Positive 1 is at 360 degrees. Do you see the pattern? They are separated by 180 degrees. So I'm going to say that theta is 0 degrees plus 180 degrees k, where k is any integer. You do not have to put the 0 degrees as a placeholder, because when we state that it's 180k, where k is any integer, 0 is an integer, so it will take care of that. But if you like to get into the habit of having that first location, you're more than welcome to put it. Okay, so I'm going to pause my video. You pause your video, give it a whirl, and then we'll see what happens. Okay, so take a look at B. Hopefully you guys tried it. With this one, we get that cosine, of theta is equal to rad 3 over 2. Okay, so that means that we're only going to be in the first and the fourth quadrant because that's where cosine is positive. Rad 3 over 2 means that it's the cosine of 30 degrees, or pi over 6. Here, they're not separated by any consistent measurement, so we need to list them out as 30 plus 360k and 330 plus 360k, where k is any integer. There's not a consistent space between them like there was in the try this A. For the try this C, be careful when you take the square root, you get the square root plus or minus the square root of 1/2, and then you have to rationalize, so you get rad 2 over 2. Now, ooh, Nelly, I did forget. Ooh, there we go. Notice it's 45, 135, 225. They're separated by 90 degrees. So I wrote mine as one statement. 45 plus 90 degrees k, where k is any integer. You are more than welcome to do 45 plus 360k, and 135 plus 360k, and 225 plus 360k. It doesn't matter if you want to do individual sentences across the board or if you want to combine them into one sentence if there's a consistent distance between the answers. Okay, so now you have that option. Mrs. Dahl and I on our answer keys usually will write it as one if we can, but that doesn't mean that you can't write them out as individual sentences. Okay, alrighty. Now, example number 3, notice we have sine squared and cosine squared. I don't want to solve for 2 different trig functions. And it says for all values of x in degrees. Okay, so be careful of that. So I'm going to pick one to change. And I'm actually going to change cosine squared using the Pythagorean identity. I'm going to say sine squared of x minus 1 is equal to 1 minus sine squared x. And then I'm going to add sine squared x, so I get 2 sine squared x, and I'm going to add 1 to the other side is equal to 2. I'm going to divide by 2, so I get sine squared x is equal to 1. I remember that this is the same as sine of x quantity squared, so I take the square root and I get sine of x is equal to plus and minus 1. I then have to take the inverse, so I get sine inverse of plus and minus 1, and I get x, remember, degrees, is equal to, the first place is 90 degrees, the next one is 270, and so forth. So I'm going to say that x is equal to 90 plus, they're separated by 180 degrees k, where k is any integer. Yes, you can put it into 2 separate sentences, what sentences, okay, but I'm not choosing to do that. Now, let's say that you wanted to change sine squared. That's okay. I would get 1 minus cosine squared of x minus 1 is equal to cosine squared of x. The ones would cancel. I would get 0 is equal to 2 cosine squared of x if I added the cosine squared of x to the other side. And then if we divide by 2, we end up with, oh my, come back, there we go. Cosine squared of x is equal to 0. Again, this is the same as the cosine of x quantity squared is equal to 0. So the cosine of x, if I take the square root of both sides, is equal to 0. X is equal to the inverse cosine of 0. And where is that? Oh, hey now, it's at 90 degrees and 270 degrees and so forth. Exactly the same answer. Okay, so please know that you have the freedom to choose which one you want to change. You should get the same answer. Okay, I'm actually going to, let me see real quick. Yep, I am going to try this with you right here. Okay, I'm going to switch back to black. And notice, okay, first off, we're in radians and we're given an interval, okay? And it looks very similar. Let's say I'm going to let x equal the cosine of theta. If I do that, I get 2x squared minus 3x minus 2 is equal to 0. What is that? Ho, ho, ho! It's a quadratic. So I'm going to use the x method, and I need to know what multiplies to -4 but adds to -3, -4 and +1. So I'm then going to substitute it in. Now some of you I know like to use guess and check for the quadratics. Totally fine with that. This is just my preferred method. I substitute those two numbers in for the middle term. I factor by grouping. Pull out the GCF, I get 2x, and I'm left with x minus 2. I pull out a +1, and I'm left with x minus 2. These are the same factors, so I pull that out, and I'm left with 2x plus 1. Now, you can't just go ahead and solve. Be careful, because what did we do? We let x substitute in for the cosine of theta. So really, I'm solving cosine of theta minus 2 times 2 cosine of theta plus 1 is equal to 0. Super awesome, right? Now, you don't have to use the let x equal cosine of theta. Okay, it's just to help us see that it is a quadratic. But if you want to, you can. And then I'm going to let both of these factors, thank you, zero product property, equal to 0 and solve. Now on the left-hand side, I get the cosine of theta is equal to 2. But I vaguely remember Patterson saying over and over and over and over and over and over again that, in fact, it was a test question, that the cosine ratio can never be greater than 1 because the hypotenuse is in the denominator and the hypotenuse is always the longest side. So this can't happen. I can't solve it. But I can solve the right factor. So 2 cosine theta equals -1 when I subtract it to both sides. Cosine of theta is equal to -1/2 when I divide by 2. I'm looking for an angle, so I'm going to take the inverse cosine of -1/2. Okay, it's 1/2, which means in radians, I'm looking at a pi over 3, a 60-degree reference angle, but it's negative. So I'm in the second and the third quadrant, which means it's going to be 2 pi over 3 and 4 pi over 3 for my answers. Sweet. Okay, so that being said, I know the example number 4 looks very terribly similar to the try this. So I'm going to pause my video. I want you to pause your video. I want you to try it, and then we'll come back together once we're done. All right, so yes, similarities. It is also between 0 and 2 pi. Now, I noticed that this says 0 pi. This doesn't. It doesn't matter, you guys. We've talked about that. You can put pi for 0. You don't have to. 0 times anything is 0. So is it necessary? Not really. And it factored the same. So I used my x factor from up there. And I got, obviously, again, sine of theta has hypotenuse in its denominator ratio. So it can't be greater than 1. Sine theta equals -1/2. Sine is negative in the third and fourth quadrant, and it is a reference angle of 30, which means it would be 7 pi over 6 and 11 pi over 6. For example number 4, I did not let x equal sine of theta. I just factored as is. But again, remember you have the option to substitute if you would like. All right, we have a couple more. For the try this, we're just going to do it together. Let's live dangerously. Cosine of theta and sine of theta. Ooh, they are not squared. I'm not changing anything. And I'm in degrees. Well, gosh. I think I can square both sides. What do you think? Can I do it? Am I allowed? Yes. And the reason I'm thinking about doing that is because if I subtract sine to the other side, it doesn't really get me anywhere. So I'm going to square both sides. Now, the only reason I'm allowed to do this is because I'm doing it to both sides. Now, on the right-hand side, it's 1 plus sine theta times 1 plus sine theta. Okay, don't square the individual pieces. So we're left with that. Okay. A little bit easier to work with because now things are squared. So cosine squared, I'm going to change to 1 minus sine squared theta is equal to 1 plus 2 sine theta plus sine squared theta. Okay, I'm going to subtract 1 to both sides so that cancels out. I'm going to add sine squared to the other side. So I get 0 is equal to 2 sine squared theta plus 2 sine theta. Why would I want it equal to 0? The reason is because I have a squared and I have a linear term. So I'm dealing with a quadratic. Right then and there, I know I have to set it equal to 0, otherwise I can't solve it. Okay, I can factor out a 2 sine theta. So 2 sine theta times sine theta plus 1 is equal to 0. Hello, you beautiful zero product property again. So 2 sine theta is equal to 0. Sine theta plus 1 is equal to 0. On the left-hand side, if I divide by 2, it's just equal to 0. And I'm looking for the angle, so I'm going to apply the inverse of sine to 0. Sine is 0 at 0 degrees and 180. I'm restricted. I'm not going to use k. It's not necessary. Okay. And then sine theta plus 1 equals 0. If I subtract it, I get sine of theta equals -1. I need to use the inverse. So inverse sine of -1. And that occurs at 270 degrees. So our final answer is 0, 180, and 270 degrees. Again, you don't have to put it in ascending order. Oopsies. That's going to bother me. Sorry. But you do need to put it as one solution set because these are all the solutions to the given equation. Okay. So yeah, we did work a little bit backwards. Go ahead and try example 5 on your own. Whatever will you do? Pause your video and try it. Uh-oh. I don't think I'm paused. Okay, so again, we're in degrees. Hopefully you paused and gave yourself a chance to try it. Tisk, tisk if you did not. Yeah, it's great. We just square both sides. You're allowed to do that. In doing so, you allow yourself to use the Pythagorean identities, okay? Make your job easier, not harder. Hopefully you got 90, 180, 270. And ladies and gentlemen, we just finished the last unit of the year. I do sincerely wish that I was looking at your faces right now, but hopefully I'll see you at the Google Meet, if nothing else but to say hello, and I miss you guys, and it has been an absolute pleasure to be your teacher this year. You guys are pretty awesome and full of personality that I have appreciated more than you know. Be safe.